All right, 2.7 is called composite functions. So we continue obviously with our functions, but now we're doing composite stuff. If you remember from Algebra 2, f of g, g of f, that's basically the entire thing, the entire topic that is in this section. Obviously, it just takes it a little bit further with the AP content. So first of all, these are all the things we can do with functions. We can add two functions, we can find the difference, we can find the product, we can find the quotient, and we can combine them into what we call a composite function. So the bottom thing is what the heavy focus of this section is, and that is your f of g, okay? And it could also be the other order, g of f. But that open dot or the parentheses inside the parentheses mean the same thing. It means take the second named function. So if it's f of g and g of f, then whatever comes second is what gets plugged into the first. So you'll see this in a lot of different ways. You'll see it in an equation form. You'll see it in actual data set. You'll see it in a combination of the two, or you'll see it in a graph. This is usually one of your FRQs, is a combination of this and an inverse function, which is what we'll do tomorrow. So you'll kind of see those two together. So example 1 says to find A, f of g of x, and B, g of f of x. And then the domain of those functions. So the first thing we're going to do is find the composite function, and then we'll come back to the domain and discuss what that means. So in A, I'm doing f of g of x. Follow the rules of your parentheses, right? Take the one on the inside and plug it in to the other one. So I would get 2x squared plus 1. If you could expand and FOIL or simplify or combine like terms, then you would. In this case, we can't, so we literally leave that. This is our combined function. Again, I'm going to come back to the domain after we're done with both. B says find g of f of x. And this time we take the f of x and we plug it into the g. So I'd get 2x plus 1 in parentheses squared. And if this is multiple choice, you might see that as an answer. If it's not multiple choice, then that does work as an answer, but you also might see it expanded. So if I expand the shortcut for a product, squared, is square the first term, square the last term, and then double the product. Repeat what I just said, which was, if you see something like this, so if I have 2x plus 1 and it's raised to the second power, and there's nothing like adding or subtracting that I could then combine into like terms, the 2x plus 1 squared, if it's open-ended, is a fine answer, okay? If that then said like plus 3 and I can go further to simplify it, then I expect to see expanded and FOILed. And just know that if it is a multiple choice question, you're going to see one or the other. You won't see both, okay? So the shortcut on the squares is square the first, square the last, and then double the product of the two terms. And that's how I got to 4x squared plus 4x plus 1. Question so far? Okay, now let's talk about the domain of a composite function. So the rule on domains of composite function, okay, if it says, if it says find the domain of this function, then you have to do two things. You have to check the domain of your initial function, inside the parentheses, or second, because you could write it both ways. Okay, meaning if it said f of g of x, then I have to check the inside function for a restriction domain. If the second function, or the one inside the parentheses, has a restriction, then it gets carried down with your composite function. So if g of x in that case had some sort of restriction, now think domain restrictions like can't be, if it's under the square root, it can't be negative. If it's in the denominator, it can't be 0, and then the combination of the two. If either of those happen, then that gets carried down into my final domain restriction. But then after I make the composite function, I also have to check for the new four additional domain restrictions. So if it asked me to find the domain restrictions of f of g of x, I would have to check g of x first, see if there's anything restricted there. Then I would take the g of x, plug it into the f of x, and check the updated one to see if there's any domain restrictions there. If it was g of f of x, I'd have to check f of x for a domain restriction and then check my composite function, the f of g of x. So in the case of these, for A, it's f of g. I would go back to the g of x and I would check to see if there's a domain restriction. Is there a domain restriction on x squared? No. Then I would check my updated function, which is 2x squared plus 1, and see, is there a domain restriction there? No. So the domain on this composite function is all real numbers. Negative infinity to positive infinity, or all real numbers. Now go to B. B is g of f of x. So the first thing I'm going to check is f of x. Is there a domain restriction on 2x plus 1? No. Then check my composite function, this one or this one, doesn't matter which one you check. Is there a domain restriction on that one? No, so my domain is also all real numbers or negative infinity to positive infinity. Questions on any of those? This one or here? You mean here? Yeah. All right, so now look at this one. Again, A says f open dot g. That means the exact same thing as f of g. And B, g of f means the same thing as g of f of x. So the first thing I'm going to do for A is take my g and plug it into the f of x. And I'd get 1 over x plus 3. That's my composite function. For B, it's the reverse. I'm doing g of f, so the f gets plugged into the g. And I do 1 over x plus 3, and that's my composite function. You will also see something like that rewritten, like it gives it its same denominator. It would be times x here and times x here, and I'd get x 1 plus 3x over x. Know that these are the same thing. So a lot of times it would be like that in a multiple choice, okay, where it would be rewritten as one fraction. They are the same thing. If it's open-ended, I'd take either answer. Now you got to check your domain restriction. So on A, the first one I'm going to check is the trig function, or the function that comes at second, or on the right-hand side, which is g. So if I go to g of x, is there a domain restriction? No. Now I have to check my new composite function. Is there a restriction on 1 over x plus 3? Yes. What is it? X cannot equal negative 3 because my bottom can't be 0. So my negative infinity to negative 3 parentheses negative 3 to positive infinity, is it written in interval notation, in words, or in inequality form would be the other way, and it would be x cannot equal negative 3, or all numbers except where x equals negative 3. Any of those could be written. Okay, now we go to B, and B was f or g of f of x. So I'm going to go to my f of x function. Is there a domain restriction from that? Yes. So from the beginning, what's the domain restriction? X cannot equal 0. So I carry that down with it. So even if I made a new function in which the x was no longer in the denominator, or it said something like x plus 1 in the denominator, for example, then I still carry down that x can't equal 0, and then I check my new function, which is this guy or this guy, for any additional restrictions. It is the same restriction, just repeated. So I get negative infinity to 0, and then 0 to positive infinity. This one. Yeah. So I took this and gave it a like denominator.
The one before, I'm confused how you got there.
Oh, I took the f and plugged it into the g. So the x here becomes 1 over x, and then it would have been plus 3. So like, for example, let's say I had 1 f of x equals 1 over x plus 1, and g of x equals x plus 2. So f of g, actually do it the other way around. G of f of x find that, and find the domain restrictions. All right, so first thing I'm going to do is take the f of x and plug it into the g of x. And I end up with 1 over x plus 1 plus 2. Now I check for a domain restriction. So from the initial one, what's your domain restriction? X cannot equal -1. Then I check my new updated one. Is there anything new? No. So what's the domain restriction? -1 to, negative infinity to 2? -1 and -1 to infinity. Now do the reverse. Now do f of g of x. Yeah.
For the first one, I put the 2 in the fraction.
You have 2x plus 1 like this over the whole thing?
Yeah.
That's fine.
I have 2x plus 3.
So 2x plus 3. Yeah, that's fine. Plus 3 over x plus 1. If it's open-ended, either are going to be right. If it's multiple choice, you'll only see one. Yep. All right, so now do the reverse, right? Take the g and plug it into the f. And I end up with 1 over x plus 2 plus 1. And my answer would be 1 over x plus 3. That's the composite function, right? Now think about your domain. So from my initial function, is there a domain restriction on x plus 2? No, there's nothing for here. But when I bring it into the bottom, now this cannot equal 0, so x cannot equal -3. So sometimes your domain restriction will come from the original. Sometimes it comes from the composite. Sometimes there's both. You have to account for both, but only the one that comes second. Like if it is f of g of x, I don't worry about the original f of x because I have to take g to plug it into f before I do anything with that function.
What else might there be a restriction other than a fraction?
Like a square root. Like I could have f of x equals square root of x plus 3, and then I could have g of x equals 1 over x. Now you've got 2 domain restrictions, right? So if I do f of g, then the domain restriction here is going to carry down. So x could not be 0. And this would be inside the square root like this. So that has to be greater than or equal to 0. The fact that we made it not equal to 0 will overtake those. I would say more often than not, it'd be the other way around. So if you said g of f of x, now I've got a domain restriction here. X would have to be greater than or equal to -3. And then when I put it in the bottom, what happens? Now it can't equal 0. So it goes from greater than or equal to just greater. X would be greater than -3. So it changes from a bracket to a parentheses. All right, example 3 now gives it in a different way. So 2 other ways you're going to see composite functions. And the FRQs, if it's an FRQ, will usually give you an f of x, that's an equation. A g of x, that's a graph. And an h of x, that's a chart of information. And it will ask you to find multiple things. So you've got to be able to pull your information from an equation, from a graph, and from a data set. So it says use the graphs of f and g to find, well, I shouldn't say graph of f of g, but the graph of f and g to find the following. So A says find f of g of 2. I go inside parentheses first. So g of 2 tells you, go to g of 2, g is this guy, right? And go to where the x is 2 and get that answer. So g of 2 is actually 2. And then replace g of 2 with its value, which is 2. Now find f of 2. If I go to the f graph, I want to know what's happening at 2. What's the y at 2? 0. B, find g of f of 2. So now I'm finding f of 2 first. We just said f of 2 is 0. And then I want to find g of 0, and g of 0 is 4. C says find f of g of 0 minus f of 3. So notice that this is inside the parentheses. I'm going to do that first. G of 0, we just said was 4, minus f of 3. 3 is here. The y is 2. So I'm going to find f of 2, and f is back to my graph. F of 2 is 0. These types of questions should be pretty easy by the time you get to them, especially they'll throw in the inverse functions on these too, like you're guaranteed, I would say, to see something where there's a combination of those. But you have to be really careful. Like if you go to the wrong chart or the wrong graph, obviously, or if there's an equation, you grab the wrong thing, that's when you can make an easy mistake. Any questions on that? All right. Example 4 says given f of x equals x squared minus 4 and the graph of g, find 2f of g of x when x is 1. So it's telling you x is 1. I'm going to take that 1 and plug it in. I'm going to find 2 of f of g of 1. And what am I going to find first? G of 1. G is the graph, right? So I go to where g is 1. Now this would be 1, 2, 3, 4. It actually tells you g of 1 is here, which would be what? Negative 2. So then 2 f of negative 2 is what I have next. And now I want to do f. F of negative 2 says take your f function, f of x, which is here, and plug negative 2 into it. Negative 2 squared minus 4. It's important to keep it in parentheses because that negative is inside, so it gets squared. This becomes 4 minus 4, which is 0, and then 2 times that gives you 0. Questions on that one? All right, example 5 says given h of x equals f of g of x, decompose h of x by identifying a valid f and g. So we are working the other way around. What they're giving you is a composite function, and you have to break it down into two functions where if I plugged one into the other, I would get this as its an answer. We're working backwards.
So can there be multiple?
There can be multiple answers, yep. Usually I would say take whatever the parent function is. So if I have something that is squared or an absolute value or in a fraction, I make the one they're getting plugged into. So that would be my f. And then whatever is inside the parentheses or in the denominator or inside the absolute value or under the square root, I make my g. Because if I plug that into the other one, I get the composite function. So if you think about it that way, the parent function here is x squared, right? Like if I took this and raised it to a power, it would be x squared. So if I make f of x, x squared, what would I plug into that x to make it this composite function? 2x plus 1. So I can make g of x 2x plus 1. And then I would check it and make sure it works. So if I take this and I plug it in here, do I end up with my question? And the answer is yes, okay? So to me, that's the easiest way to look at it. Figure out what your parent function would have been, make that your f of x, and then whatever alterations you're doing to that, make that your g of x. So if I look at b, what would be the parent function? 1 over x. So f of x equals 1 over x. And then g of x, what would I have to plug into that x to get it to be 1 over x minus 2? X minus 2. Does that make sense? Okay. Now let's say it said something like plus 4 here. I would make that part of my parent function. Anything that's inside the denominator, inside the absolute value, or underneath the square root, all that horizontal translation stuff, that could be your g of x. But then the vertical I would keep as part of my f of x because that affects it differently. So if there was like a 2 on the front from the beginning, let's say it said 4 here, then I would make this 4 on the outside. Only the h of x, only the horizontal part is what I make the g of x. But again, there is more than one way to do this. For me, that's how my brain breaks it apart. Questions on those?
What's g of x equal to the second one?
I erased it. It was x minus 2. I think I hit undo one too many times. All right, example 6 says match the correct f of x and g of x to produce the given composite functions. So you are trying to figure out what g do I plug into what f to get the ending result. So let's say I start here. Am I highlighted? No. Let's say I start here, okay? What g gets plugged into which f to get me to that spot? The g is your x squared, so if I make g my x squared, which one would I plug it into? The first one, okay? First of all, there's only 1 plus 1, so that's kind of a hint where you're going with that. But if I take that x squared and I plug it into the x on the exponent, I end up with the ending one. Go to the next one. F of g of x equals e to the 6x. What result would get me here? Which g gets plugged into which f? E of 3 of x could get plugged into x squared. If I take this and I square it, this squared, it becomes e to the 6x. Because when we raise the power to a power, we multiply. All right, and then obviously last, the e to the 3x squared plus 3, if I take g of x being x squared plus 1, and I plug it into the exponent with that 3, then I get the one I'm looking for. Questions on that one? All right, last slide. Example 7 says, given f of x equals x minus 2 and the graph of g of x, graph g of f of x, and then graph f of g of x. So given f of x equals x minus 2 and the graph of g of x, graph f of, or g of f of x, means I'm going to take this and I would plug it into this, whatever that function is. So if g of x, oops-a-daisy, g of x becomes g of x minus 2, what would I be doing with that graph? What translation occurs? To the right 2. So every single point I have on this graph gets shifted over 2 spots. And my new function would look like that. So if it's happening inside the parentheses, remember it is your horizontal translation. If it was something outside the parentheses, then it would be a vertical translation. Questions on that one? So if it had said f of x equals 3x, what kind of shift would that cause? Good. Vertical dilation by a factor of 3. I'd have to take all those points and multiply them, all the y's, and multiply them by 3. Questions? Thank you. Okay, then it says graph f of g of x. So now the g of x would get plugged in here. So if that whole graph was plugged into the x, this would be g of x minus 2. What shift is that? Down 2. So all these points would go down to I graphed the wrong one. Hang on, sorry. This is the original one. That would be your f of g of x. Thank you.